Earlier in the course, you learned a little bit about objects. You learned that objects are collections of key value pairs. So if we have properties that are highly related, we want to encapsulate them inside of an object. Here's an example. Let's say we're building an application for drawing different kinds of shapes, like circles, rectangles, and so on. So we could declare multiple variables around circles. For example, radius, we set that to 1, then x and y. We're defining multiple variables, but all these variables are highly related. They represent a circle. A better approach is to put these variables inside of an object. Now we can send that object anywhere in our program. We can pass that to any functions, and all these variables will be available in that object. So I'm going to define an object. We could use let or const. In this case, it doesn't really matter. So let's define a circle object using the object literal syntax. So we add these curly braces, and inside them we add one or more key value pairs. So the first key is radius, and the value is 1. Now this value we have here can be any type in JavaScript. It can be a number, a string, a boolean, null, undefined. It can even be another object or an array or a function. Let me show you. So instead of defining two other key value pairs as x and y, I'm going to add a key called location and set its value to another object. Now in this object, we can have two key value pairs or properties. The first one is x and the second one is y. We can also have another property here like is visible and set that to a boolean, true or false. Okay? So the purpose of an object is to group related variables. But it's not just grouping related variables. Quite often we have functions that should operate on these variables. For example, we can have a function like draw for drawing a circle, or we could have another function for moving a circle, right? So again, these functions are highly related to these variables we have defined here. So instead of defining these functions in a standalone way, it's better to put these functions inside of the circle object. Again, with this, wherever we have a circle object in our program, we have access to all its properties and functions. So let me show you how to add this draw function inside of the circle object. We add another key value pair. The key is draw, and the value is a function. So I told you that the value of a key value pair can be anything in JavaScript. Here, the value is a function. Now for simplicity, I just want to do a console.log here. Let's log draw on the console. So now with this circle object, we no longer need these independent variables and functions. All of these are now part of a circle object. So we can access them using the dot notation, circle dot. Look, all of them are here. We can simply call this draw function like this. And if I save the changes, you see the draw message here. Now, what you see here is what we refer to as object-oriented style of programming. So object-oriented programming, also abbreviated as OOP. Object-oriented programming is basically a style of programming where we see a program as a collection of objects that talk to each other to perform some functionality. So here we have a circle object, and this object has a few properties and a function. In object-oriented programming terms, if a function is part of an object, we call that function a method. So here, more accurately, instead of saying we're calling the draw function of the circle object, we say we're calling the draw method of the circle object. Okay, so draw method. So that's the difference between a function and a method. If a function is part of an object, in object-oriented programming terms, we refer to that function as a method. Now, using this object literal syntax is an easy way to create an object, but as our applications get more complex, we need a different way to create objects. And that's what you're going to learn next. You learn how to use the object literal syntax to create an object. But there is a tiny problem here. Imagine we want to create two circle objects. So I'm going to copy this code here and call this second circle object circle2. Now the problem we have here is that we have duplicated the implementation of the draw method. So right now it's a simple method. It has only a single line of code. But what if we had 10 lines of code here? We wouldn't want to repeat all these lines here, because if we have a bug in this method, then we would have to fix it in multiple places. And also take into account that our circle object currently has only a single method. What if we had 10 other methods here? We don't want to duplicate or repeat all that logic, right? So if our objects have logic, we need a different way to create objects. That's when we use factory or constructor functions. In this lecture, you're going to learn about factory functions, and we'll look at constructor functions next. So I'm going to delete this second circle and show you how to create a factory function. So factory function. Just like a factory producing products, these factory functions produce objects. So we define a function and call it create circle. Now we're going to move this definition of the circle object inside of our factory function. So we have a circle object here. Finally, we need to return this. Now, one way is to return it like this, but we don't really need this circle constant defined because we are not going to reference it anywhere. We only want to return it. So we can make this code shorter by removing the circle constant and simply returning this object. So whenever we call the create circle function, we'll get a circle object. However, we have hard-coded these values here. So every circle that is created by this function, its radius will be 1. That's not what we want. Maybe we want to have a circle with a bigger radius. So we want to pass radius as a parameter here. So radius. And then instead of hard coding 1, we want to set the value to this radius argument that we supply when calling this function. Similarly, we can add another parameter here like location. And instead of hard coding this object here, we can simply set location to this location argument. However, for simplicity, I'm going to remove these two properties, location and is visible, so we can focus on the core of factory functions. So let's delete these properties. We don't need the location parameter either. Now we can make this code a little bit shorter. So in modern JavaScript, if our key and value are the same, we can make our code shorter by removing the value and simply adding the key. So that is exactly equivalent to this code, right? So that is better. Next, we have our draw method. There is also a shorter syntax to define this method. So instead of defining it as a key value pair, we can define it like this. So draw, parentheses, and a code block. This is similar to how we define a function outside of an object, right? So if you want to define a function, this is how we define it, right? So we have the function keyword, then the name of the function, parentheses, and code block. Now, when we put this inside of an object, basically we're dropping the function keyword and simply adding this inside of the object. You can see this syntax is a little bit shorter than what we have here. So let me delete this and move this console.log statement in our draw method. So now we have a factory function. We can simply call this to create a circle object. So I'm going to define this constant circle1 and call the create circle function and pass 1 as the radius. Now let's log this circle object on the console. Circle1, save the changes. So you can see radius is set to 1. We also have this draw method. So we can call circle1.draw, and here's our draw message on the console. Now the beauty of this factory function is that we have defined our logic in one place. So we can call this function with different values or different arguments. We get different circle objects, but we have defined the draw method only in one place. So if there is a bug in this method that we need to fix in the future, there is a single place that we need to modify. So now I'm going to create another circle object, circle2, create circle. I'm going to pass 2 as the radius. Let's log this on the console, circle2, save the changes. Look, we have 2 different circle objects and a single definition of the draw method. So this is all about factory functions. But factory functions are not the only way to create objects. We can also use constructor functions, and that's what you're going to learn next. You're going to learn about another pattern for creating objects. That is a constructor function. So just like the factory function, we're going to create a function, and the job of this function is to construct or create an object. However, the naming convention we use for constructor functions is different. So the naming convention we have for factory functions is what we call camel notation. So the first letter of the first word is lowercase, but the first letter of every word after is uppercase. This is what we call camel notation. So it looks like this. Camel notation. We've got 1, 2, 3, 4. You can see the first letter of the first word is lowercase. And these uppercase letters look like camel humps. That's why we call it camel notation. In contrast, we have another notation that is called Pascal notation. And in this notation, the first letter of every word should be uppercase. So 1, 2, 3, 4. You can see the pattern, right? Now, when naming constructor functions, we should use Pascal notation by convention, because that's something that other JavaScript developers expect when they read your code. So we're going to call this function circle with a capital C. Note that I did not call this create circle, and you will see that in a second. Now, just like our factory function, here we need to add a parameter, radius. However, instead of returning an object, we're going to use a different approach to initialize an object. In JavaScript, we have a keyword called this. And this is a reference to the object that is executing this piece of code. You're going to see that in a second. For now, just imagine this references an empty object. Now, you know that with dot notation, we can access properties of an object, we can read a property, or we can set a property. So on this new empty object, we want to add a property called radius, and we set that to this radius argument that we receive here. So in JavaScript, our objects are dynamic. Once we create them, we can always add additional properties or methods to them. So here we're adding a new property to an empty object. Now, similarly, we're going to use this approach to add a draw method to this new empty object. So this.draw, but we set this to a function. And in the body of this function, we simply do a console.log of draw. Now finally, in order to create a circle object using this constructor function, we're going to define a constant called circle. And here we're going to use another keyword that is new circle and pass 1 as the radius. What is happening here? Well, when we use this new operator here, 3 things happen. This new operator creates an empty JavaScript object. Something like this, constant x set to an empty object. That is happening under the hood, but you don't see that. Next, it will set this to point to this new empty object. So in this code, we have access to this new empty object, and we set this radius property as well as the draw method in this new object. Finally, this new operator will return this new object from this function. So it looks like this, return this. We don't have to explicitly add this statement here in this function. This will happen under the hood. So let me recap. When we use the new operator, 3 things happen. This operator first creates an empty object, then it will set this to point to this object, and finally it will return that object from this function. So what we get here is that new object, and we simply set circle to point to that object. Now let's see the difference between factory and constructor functions. So with factory functions, we create an object like this. Constant, my circle, here we call create circle and pass an argument. So with factory functions, we simply call a function, and in this function we return a new object. In contrast, with constructor functions, we use the new operator, and instead of returning an object, we use the this keyword. Also, in terms of naming convention, with constructor functions, we use the Pascal naming convention. But in factory functions, we use the camel notation. So you might be asking which approach or which pattern you should use to create new objects. Both these patterns are equally good for creating new objects. The constructor function pattern is familiar to developers who have some experience programming in languages like C# or Java. So with this pattern, you can see we're creating a new circle. Now, if you don't have any experience in languages like C# or Java, you might want to go for a factory function. There is really no difference between these two patterns. However, there are some discussions online by some strongly opinionated developers comparing these two patterns. My suggestion to you is do not get hung up on these discussions. They're just a waste of time. Pick one pattern and just stick to that. To understand about objects in JavaScript is that they are dynamic, which means once you create them, you can always add new properties or methods or remove existing ones. So here we have a circle object with a single property that is radius. We can add another property like color, set it to yellow. Now, when we log the circle on the console, we can see we have two properties, color and radius. Similarly, we can add a new method here, circle.draw. We set it to a new function. And now, when we log this on the console, you can see our circle object has three members, two properties, color and radius, and one method. We can also delete existing properties or methods. So here, before logging the circle, we can use the delete operator to delete a member from a circle object. That member can be a property or a method. So circle.color. You can also delete the draw method, so circle.draw. Now save the changes. You can see now our circle object has only the radius property that we added at the time of creating this object. Now, something that some developers find confusing is that here we have used the const keyword to define a new constant. However, you can see I have modified this circle object. I've added a property and then removed that property. So what kind of constant that is? Well, when we use constant here, that means we cannot reassign this variable. So this variable is more accurately a constant. So we cannot reset circle to a new object. If we do that, we get this error, assignment to constant variable. So we cannot reassign this constant, but we can always change the circle object by adding or removing properties. Object in JavaScript has a property called constructor, and that references the function that was used to construct or create that object. So here we have two objects, circle and another. Let's look at the constructor property. So here on the console, another dot constructor. So as you see, this returns our circle function that we used to create this object. Now let's look at circle dot constructor. What is this? Well, you can tell that this is a function because here we have this blue F. And as you can see, the first letter of this function is uppercase. So this is a built-in constructor function in JavaScript. When we create an object using the object literal syntax, internally, the JavaScript engine uses this constructor function. Let me show you. So I'm going to temporarily delete all this code. Let's define an object like this. When we use this syntax, object literal, JavaScript engine will translate that to something like this. Let x equals new object. Okay, so this circle object, we created and returned it from our factory function. And because we use the object literal syntax, internally it was created using this object constructor function. In JavaScript, we have a few other built-in constructors. For example, we have string for creating strings, but quite often we use string literals. So single quote or double quote, or backtick. Using these literals is cleaner and simpler than using the constructor. We also have Boolean, but again, we don't use this. We either use true or false. So we refer to these as Boolean literals. We also have number, but instead we use number literals, like 1, 2, 3, whatever. So this is what I want you to take away. Every object has a constructor property, and that references the function that was used to create that object. One of the confusing concepts in JavaScript is that here functions are objects. So this circle function we have here is actually an object. Don't believe me? Let me show you. So circle dot, look, these are all the members of this circle function or circle object. So the purple icons are methods like call, bind, and apply, and the blue icons are properties. So let's take a look at a few of these members in the console. Here in the console, circle dot name, that returns the name of this function. Circle the length returns the number of arguments. Now earlier in the last lecture, I told you that every object in JavaScript has a constructor property, and that references the function that was used to create that object. Now here's the interesting part. Who do you think created this object? Let's have a look. So circle dot constructor. So here we have another built-in constructor called function. And when we declare a function using this syntax, internally, JavaScript engine will use this function constructor to create this object. Let me show you. So I'm going to define a constant called circle1 to separate from our circle. Set it to new function. Now here our function requires one parameter, radius. So we add that here as a string. Now as the second argument, I'm going to pass the code inside of this function. So to break it up into multiple lines, I'm going to use the backtick character and then simply copy all this code and put it here. So when we declare a function internally, it's represented like this. Now we can call this circle1 just like calling our circle function. So we can create a circle object by newing up circle1 and pass 1 as the radius. Save the changes. Now in the console, let's log circle. Look, it's a real circle object with these two members. Now let's take a look at a couple of methods that are available in our functions. So I'm going to delete all this code. Circle dot. Here we have this call method. And with this, we can call a function. Look at the arguments. The first argument is this argument. Here we need to pass an empty object, and this will reference this object that we pass here. Okay? Now after that, we add our arguments explicitly. So here we have one argument, we pass 1. If we had multiple arguments, we would pass them explicitly like this. Okay? So this expression is exactly like expression on line 11. When we use the new operator, this new operator will internally create an empty object and pass that as the first argument to the call method. And this object will determine the context for this. So this will reference this object. Earlier, I told you that if you don't use the new operator, this by default will point to the global object, which is window. So if I want to rewrite this expression in this way, instead of passing an empty object, I would pass window. Of course, we don't want to do this. I'm just explaining to you what happens under the hood. So let's revert this back. So the first argument here specifies the target of this. Okay. Now we have another method called apply. It's exactly like the call method. With this, we can call a function, But instead of passing all the arguments explicitly, we pass them in an array. So this is useful if you already have an array somewhere else in your application and you want to pass that array as the second argument to the apply method. So this is the takeaway. In JavaScript, functions are objects. Two categories of types. On one side, we have value types, also called primitives. On the other side, we have reference types. So in the value types category, we have number, string, boolean, symbol, which is new in ES6. We're going to look at that later in the course, as well as undefined and null. These are the primitive or value types. On the other side, we have objects, functions, and arrays. So in the last lecture, you learned that functions are also objects. The same is true about arrays. So in a nutshell, in JavaScript, we have primitives and objects. Now in this lecture, I'm going to show you how primitives and objects behave differently, because this is absolutely important for you to understand before we move on to the next section where I talk about prototypes. So on this empty canvas, I'm going to define two primitives, x and y. I'm going to set y to x. So here y is 10. Now I'm going to change the value of x to 20. What I want you to note here is that x and y are two independent variables. So let's save the changes, go back in the console. Let's log x is 20, and y is 10. They are independent. So when we work with primitives, this value that we have here is stored inside of this variable. When we copy that variable, that value that is stored in the variable is copied into this new variable. So they are completely independent of each other. Now let's see what happens if we use a reference type or an object here. So I'm going to change this to an object that has a property called value. And then instead of setting x to 20, I'm going to set x.value to 20. So save the changes. Back in the console, let's log x. So you can see value property is 20. Now let's log y. You can see the value property of y is also 20. So this is the takeaway. When we use an object, that object is not stored in this variable. That object is stored somewhere else in the memory, and the address of that memory location is stored inside that variable. So then when we copy x into y, it's the address or the reference that is copied. In other words, both x and y are pointing to the same object in memory. And when we modify that object using either x or y, the changes are immediately visible to the other variable. So here's the conclusion. Primitives are copied by value. Reference types or objects are copied by the reference. Let's take a look at another example. So I'm going to define a function called increase that takes a number. And here we simply increase this number by 1. Let's declare a number variable and set it to 10. And then call increase and pass this number. Now, if I log this number on the console, what do you think we're going to see? Let's have a look. So save the changes. We see 10. But didn't we increase the number? Well, when we call increase and pass this number variable, its value is copied into this parameter that is local in this function. So this number variable here is completely independent of this other number variable. Here in this function, we increment number by 1, so it will be 11. But after this function, this number is going to go out of the scope. So when we log this number on the console, we're essentially dealing with this first number. So I told you that primitives are copied by their value. So here we're dealing with two independent copies. That's why we see 10 on the console. Now let's change this to a reference type or an object. So I'm going to change 10 to an object that has a value property. Okay, let's rename this variable to object. And similarly, I'm going to rename this parameter in this function to object, and then increment object.value. Now, when we log this on the console, what do you think we're going to see? We're going to see 11. See? We got this object with value 11. The reason for this is because when we call increase and pass this object is passed by its reference. So this local parameter that we have here will point to the same object that we defined here. So in this case, we are not dealing with two independent copies. We have two variables that are pointing to the same object. So any changes we make to this object will be visible to the other variable. So remember this. In JavaScript, we have value types, also called primitives, as well as reference types, which are objects. Our primitives are number, string, boolean, symbol, undefined, and null. Primitives or value types are copied by their value. Reference types or objects are copied by their reference. We have this circle object with the radius property and the draw method. Earlier in the course, you learned how to use the for in and for of loops to iterate over the properties in an object. So in this lecture, I'm going to review this one more time to make sure you fully understand how everything works. So first, let's take a look at the for in loop. For let key in circle. With this, we can iterate over all the properties and methods of an object. Now we can log the key on the console. So we have radius and draw. And if you want to get the value of a property, we use the bracket notation here. So as the second argument here, we pass circle of key. So we're using the bracket notation to get the value of this key or this property. Save the changes. So you can see the value of radius is 1 and the value of draw is a function. And here's the implementation of our draw function or draw method. Now we also have this new for of loop. Let's take a look. So for let key of circle, we simply log it on the console. Now when I save the changes, we're going to see an error. Circle is not iterable. So earlier I told you that the for of loop can only be used with iterables such as arrays and maps. We have not learned about maps yet. We're going to look at them later in the course. What you need to know is that an object is not iterable. So we cannot iterate it using a for of loop. However, we have this method object.keys of circle. With this, we can get all the keys in our circle object, and this will return an array. And since arrays are iterable, we can use the for of loop to iterate them. Now save the changes. Again, we get radius and draw. Now let's take a closer look at this method here. So earlier you learned that this object is a built-in constructor function. So somewhere we have this constructor function like this. And whenever we create an object using the object literal syntax, internally that is translated into a call to this constructor function. So when we create an object using the object literal syntax like this, value is 1, internally that is translated to a call to this object constructor function. So that looks like this, new object, right? Also, you learned that all functions in JavaScript are objects. So they have properties and methods that we can access using the dot notation. So when we type object dot, you can see all the properties and methods defined in this object. So here we're using the keys method, and this method returns a string array which contains all the properties and methods in this object. We have another similar method to object.keys. Let me duplicate this. That other method is called entries. So instead of returning the keys as a string array, it returns each key value pair as an array. Let me show you. So let's rename key to entry. And to do that, we can press F2 to rename all the references to this key variable. Let's change that to entry. You can see that is updated here as well. Save the changes. So you can see each entry is an array. The first element in this array is the key, and the second element is the value. So that is also another way to get access to all the properties and methods in an object. And finally, sometimes you want to see if a given object has a given property or method. To do that, you can use the in operator. Here's an example. If radius as a string in circle would display a message like yes. With the in operator, you can see if a given property exists in a given object. Let's save the changes so we get yes here. But if I change radius to, let's say, color, we are not going to see the yes message now. Save the changes, yes disappeared. So the simplest way to enumerate the properties in an object is using the for in loop, but we can also use the for of loop along with object.keys and object.entries. And finally, to see if a given property or method exists in an object, we use the in operator. In the last lecture, you learned how to enumerate the properties of an object. Now, using this technique, we can get all the properties in an object and copy them into another object. So let's say we want to create another circle object, which is a copy of the circle object here. I'm going to call that another. So constant, another. Initially, we set it to an empty object. Now we can use the for in loop to iterate over all the properties in this object and copy them into this new object. So for let key in circle. Now we use the bracket notation to access a property with the given key. So we set another of key to circle of key. So basically here in the first iteration, key will be radius. So this code will be equivalent to this. Another of radius. So we're setting the radius property of another object to circle of radius. Now here on the right side of the assignment operator, we are reading the radius property of the circle. The value of this property is 1. So we'll get 1 and put it in the radius property of the another object. Okay. Now let's log another on the console. Save the changes. So here we have this radius property is set to 1. And here's our draw method. So if we call another.draw, everything works as we expect. Beautiful. But this approach for copying or cloning an object is a little bit old. In modern JavaScript, we have better ways to achieve the same thing. One way is to use the object.assign method. Let me show you. So I'm going to comment out these few lines. We have this object that you have seen before. This object has a method called assign. Now here as the first argument, we can pass a target object, which can be an empty object or an existing object. You will see the difference in a second. And then we can pass one or more source objects. Let's say circle. What this method does is that it takes all the properties and methods in this source object and then copies them into this new object and finally returns the result here. So this line of code is exactly equivalent to these 3 lines. If we save the changes, we get the exact same result. Now this target object that we pass here doesn't have to be an empty object. It can be an existing object. It can have one or more properties or methods. So as an example, let's add a color property here. We set that to yellow. Now save the changes. So this new object has the color property that we initially had here, as well as the members of the circle object. So this is the object.assign method. Now let me revert this back to an empty object. I'm going to show you yet another simpler and more elegant way to clone an object. We can use the spread operator. So another, here we set this to a new object, and then use the spread operator, which is 3 dots, to spread this circle object. Basically what this operator does is that it takes all the properties and methods in this object and puts them here in between these curly braces. So this is the simplest way to clone an object. Save the changes. Again, we get the exact same circle object as before. So here's what I want you to take away. Object.assign copies the properties and methods from one or more source objects into a target object. And we can use that to clone an object or combine multiple objects into a single object. And the spread operator is used to spread an object, which basically means getting all its properties and methods and putting them into another object. Languages like C or C++, when creating an object, we need to allocate memory to it. And when we're done, we have to deallocate memory. But in JavaScript, we don't have this concept. We can easily create a new object. At the time we initialize this object, the memory is automatically allocated to this object. Next, we can use that. And when we're done using, we don't have to deallocate the memory. So our JavaScript engine has what we call a garbage collector. The job of this garbage collector is to find the variables or constants that are no longer used and then deallocate the memory that was allocated to them earlier. So you as a JavaScript developer do not have to worry about this. Memory allocation and deallocation happens automatically behind the scene and you have no control over that. You cannot tell garbage collector when to run and what variables to remove from the memory. So based on some complex algorithms, this garbage collector runs in the background. It figures out what variables are not used and then it would automatically deallocate their memory. In Google, let's search for JavaScript math. The first link is on developer.mozilla.org. This is your first reference for learning about all the objects in JavaScript. So let's take a look at the math object. We can see this is one of the built-in objects with properties and methods for mathematical constants and functions. So if you scroll down, you can see the properties. For example, one of the useful properties is math.pi. So this is the pi number. We have a bunch of other properties here. And below them, we've got all the methods. The first one is absolute, which returns the absolute value of a number. So if you give it a negative number, it returns its positive value. So there are a lot of methods here. I'm not going to go through each of them. It's really a waste of your time and my time. All I want you to know is that we've got this math object built into JavaScript. So in your applications, if you ever have to deal with mathematical calculations, just come back to this page and see what methods you can use. In this lecture, I'm going to give you a quick demo of a couple of these methods. The first one is the random method. So let's take a look. For each of these methods, we have a comprehensive documentation along with examples. Really, really easy. So here in the console, let's call the random method. So every time we call this method, we get a new random number between 0 to 1. Now, if you want to map this to a given range, you need a simple mathematical formula. Back to the documentation for the random method. If you scroll down in the list of examples, we can see this example, getting a random number between two values. So basically, you need a function like this that takes a min and max and generates a random number between these two values. Pretty self-explanatory, you don't need more explanation. Another useful method is math.round. So we can give it 1.9 and it returns 2. We also have math.max. We can give it a bunch of arguments and it will return the largest number in the list. Now later in the course, this is going to be one of your exercises. So you're going to write a function like the max method here that takes a varying number of arguments and returns the largest value. We also have math.min, which returns the smallest number in this list. So I leave it up to you to look at all the other methods available in the math object. The second built-in object we're going to look at is the string object. So I'm going to define a constant message and set it to a string. Now look at this, message dot. What's going on here? It looks like we have a bunch of properties and methods. But early in the course, I told you that string is a primitive type. Primitive types don't have properties and methods, only objects do. So why is it that we see these properties and methods in this string? Well, the reason for this is because in JavaScript, we have two kinds of strings. So this is what we call a string primitive, but we also have a string object. So we have this constructor function string, and we can use that to create a new string object. So we can pass the same string here. Now, because this is a constructor function, we need to apply the new operator. And now we have another string. Now let's take a look at the type of each of these constants. So type of message, that's a string, but type of another is an object. So the first constant is a string primitive. The second one is an object. However, when we use the dot notation with a string primitive, JavaScript engine internally wraps this with a string object. We don't see that, but we can work with this like a string object. Now, just like the math object, if you want to learn about all these methods, it's best to look at the documentation. So simply search for JavaScript string. Once again, on developer.mozilla.org. On this page, you can see all the properties and methods of the string object. In this lecture, I'm going to show you a few of these methods, but I strongly recommend you to look at the documentation once, just have a quick look to see what methods are there in case you need them. So back to our code, let's change this string to this is my first message. Here we have the length property, which returns the number of characters in the string. This is particularly useful in situations where you want to make sure the user types at least certain number of characters in an input field. Or maybe you want to put a limit. You don't want the user to type in more than 100 characters. Now, if you want to access a character at a given index, you can use square brackets. So message of 0 returns T, message of 1 returns H. If you want to see this string has a special word, you can use the includes method. So does this string have my? Yes, it does, but it doesn't have not. We also have another method starts with. So this string starts with this, but if you pass a capital T here, we get false. So note that these searchers are case sensitive. We have a similar method ends with, so message.ends with E. So you can see the last character here is E. If you want to find the index of a given character or a given string inside the string, you can use the index of method. So let's see what is the index of my. So my starts at index 8. We can also replace a part of a string. So replace, let's say we want to replace first with second. Pretty easy. Note that this returns a new string and does not modify the original one. So if we log the original one, we still have, this is my first message. We also have a couple useful methods to uppercase. Once again, this returns a new string where all characters are uppercase. Similar to this method, we have to lowercase. And another useful method is trim. So let me add a couple of white spaces here before and after our message. Now, if we call the trim method, it gets rid of all the white space before and after our message. And of course, this method has variations. For example, we have trim left, which only removes the white space at the beginning of the string. We have trim right, and so on. Another important concept you need to know in JavaScript is escape notation. So if you look at the documentation for the string object, you can see in this table under escape notation, we've got these special characters. So if you want to use these, you need to encode them using the escape notation. For example, let's say you want to have a single quote in your string. Now in this example, we have defined this string with a single quote. So if you want to have a single quote inside of the string, look, our JavaScript engine gets confused because it thinks this second single quote represents the end of the string. To fix this, we need to prefix this with a backslash. And now This character is escaped, it's encoded. So when we log the message, you can see the single quote is actually part of the string. Another useful escape character is \n, which represents a new line. So back here, if we add a \n after my, this will add a new line. So save the changes. Let's look at message on the console. You can see we have a new line here. Another very useful method is the split method. So message.split. With this, we can split a string based on a given character. So here I'm going to pass a white space and see what we get. We get an array of 5 items, and each item in this array is a word in our message. Next, we're going to look at template literals. In the last lecture, you learned that \n adds a new line to a string. Now, what I don't like about this approach is that it doesn't allow us to visualize what the output looks like. In other words, if we log message on the console, you can see this is what the output looks like. So on the first line, we have this is my, and on the second line, we have first message. But when writing code, our string looks different. Now, if we want to make this string similar to what the output looks like, we have to do something like this. So we break this string into 2 parts and concatenate them like this. And then we add the second part on a new line. We can also put the first part on a new line. And now this kind of looks similar to what we have in the output. But we still have this \n getting in the way, creating some noise in the code. To make the matter worse, if we want to surround first with single quotes, we'll have to escape the single quote character like this. Again, this is very, very ugly. Let's log this one more time. Very, very ugly and noisy. That's where template literals come in the picture. So far you have learned about different kinds of literals in JavaScript. So we have object literals, which are indicated by curly braces. We have Boolean literals, which are true or false. We have string literals, which are indicated by single or double quotes. Now, starting from ES6, we have template literals, which are indicated by the backtick character. This backtick character is the character before number 1 on your keyboard. So let's see how template literals help us write cleaner code. I'm going to define another constant, but this time I'm going to use a template literal instead of a string literal. So we add the backtick character. This is my. Now to add a new line, we don't need \n here. We can simply add a line break and then type first message. So we can format our string the way we want it to look like. So now let's log message and another. See, what we have in code looks very similar to what we have in the output. Now we can also put this on a new line. Now, if we want to surround first with single quotes, we can simply add them here. There is no need to escape them because we have used a different character to define our string. So save the changes one more time. Message, another. They look identical, but compare this code with the former code. This is particularly useful if you want to send out email messages in your application. For example, let's say you want to send an email to the user like this. Hi, John. Thank you for joining my mailing list. Regards, Mosh. So we can format our string exactly the way we want it to look like. There is no need for any of these plus or \n characters. So let me delete all this stuff. Now, another benefit of using template literals is that here we can add placeholders. So let's say we want to add the name dynamically. With a regular string, we'll have to do something like this. So message, we set it to hi. Then we have to concatenate this with some variable or constant. Let me define name here, set it to John. Now we'll have to concatenate this message with name, then add a comma, then \n. This is really, really ugly. Let me show you a better way. With template literals, we can add a placeholder using a $sign and curly braces. Now inside these curly braces, we add an expression. We can pass the name of a variable or a constant. Now let's save the changes. Let's take a look at another. You can see we've got John here dynamically. So this is a placeholder for our name constant. Now here we can add any kind of expression. We can also add a simple mathematical expression like this. Let's log this one more time. So, hi John 5. So technically, we can add any expression that produces a value in between the curly braces. We can also call a function that returns a value, and that's perfectly valid. So these are the benefits of using template literals. So let's see different ways to create a data object. We can create date1, set it to new date. So date is a constructor function. Now when we open parentheses here, you can see this number here, 2 of 6. That shows different versions of this date constructor. You can use the up and down arrows to cycle through these. So you can use the date constructor without any parameters, and this returns the current date time. So let's rename this to now. Let's create another data object, new date. We have another constructor with one parameter called value, which can be a string or a number, which is the number of milliseconds from January 1st, 1970, or another data object. So here I'm going to pass a string, let's say May 11, 2018, 9 a.m. Now this format is not the only format that you can pass here. If you want to find about all possible formats that are supported, simply search for JavaScript date on this page. If you scroll down, here under date string, you can read about various formats that are supported. And finally, another way to create a data object is by passing numbers. So here we have another constructor with these parameters, year, which is a number, month is also a number, and so on. So I'm going to pass 2018. Now the confusing thing about these date objects is that month is 0 based. So 0 represents January and 11 represents December. So we're going to use 4 for May. The third parameter is the date parameter, and that's the day of the month. So 11. Next parameter is hours, so 9 a.m. and minutes is 0. Now we can exclude this argument because all the other arguments are initialized to 0 by default. So this is how we create a data object. Now all these data objects have a bunch of get and set methods. For example, now.get. So get date returns the day of the month, get full year, get hours, milliseconds, minutes, and so on. We also have set methods. So let's call set full year and change the year to 2017. We also have set date, hours, milliseconds, minutes, and so on, right? Now, let's see how we can display these on the console. So save the changes. All these date objects have a few methods for converting them to a string. We can call toDateString, and we get a string like this. So Thursday, May 11. Note that we changed the year on line 6. We also have toTimeString, which returns the time component of this data object. Another useful method is toIsoString, which returns a string like this. So we have the date, then t, and time. This is a standard ISO format and is commonly used in web applications. So if you're building a web or a mobile app that talks to a backend, this is the format you commonly use to transfer date between the client and the server. Our first exercise for this section. I want you to create an address object with 3 properties: street, city, and zip code. When you do that, then create a function called showAddress that takes an address object and displays all the properties in this object along with their value. So pause the video. When you're done, come back, continue watching. So now I'm going to create an address object. We can use the let or constant keyword. In this case, it doesn't really matter. Here we're using the object literal syntax to initialize this object. So we have a street property. We set that to some value. It doesn't really matter. Next is the city property. And finally, zip code. Next, we need to create this function, show address, that takes an address object. And here to enumerate the properties of this object, we're going to use the for in loop. So let key in address, then we do a console.log of key and address of key. So here we're using the bracket notation to get the value of the given key. And finally, we call this function show address and pass our address object. Save the changes, and here's the result. The last exercise, we use the object literal syntax to initialize an address object. In this exercise, I want you to initialize an address object first using a factory function and then using a constructor function. So your exercise is to write two different functions. One is a factory function, the other is a constructor function to initialize an address object. So go ahead, and when you're done, come back, continue watching. All right, first I'm going to do the factory function. So factory functions simply return a new object. Here we can call this function create address. We should give it 3 parameters: street, city, and zip code. And here we simply return a new object with 3 properties: street, which we set to the street argument we receive. Now, as I told you before, if key and value are the same, we can make our code cleaner by dropping the value. So in this object, we're going to have these 3 properties. That's it. So that's our factory function. And we can simply create a new address like this. So instead of using the object literal syntax, we call create address and give it these 3 values. Now let's log the address on the console to make sure everything is working. Okay, here we have a new object with these 3 properties. Beautiful. Now let's write the constructor function. So constructor function. As I told you before, constructor functions have a different naming convention. So instead of camel notation that we use in factory functions, here we use Pascal notation. So the first letter of the first word should be capital. So we're going to call this function address. Again, we're going to pass 3 parameters. Now here, instead of returning an object, we're going to use the this keyword to initialize this new object. So this.street, we set that to the street argument, then this.city, and finally this.zip code. Now, to create a new address object using this constructor function, here we use the new operator and call our constructor function. Once again, we pass these values and log this address object on the console. So save the changes and we get the exact same object. So the purpose of this exercise was to help you get familiar with the syntax for creating factory and constructor functions. In the next exercise, we're going to look at object equality. In this exercise, we're going to use the constructor function that we created in the last exercise to create 2 address objects. So here's the first object. I'm going to call this address1. Now, I'm going to duplicate this line to create another address, but we're going to call this address2. Now, in this exercise, I want you to create 2 functions. One is called r=, so we pass 2 address objects, address1 and address2, and we check to see if these 2 objects are equal. Now, as I told you before, objects are reference types, so we can have 2 objects with the exact same properties, but these objects are in different memory locations. So when we use the equality operator, we're essentially checking to see if these objects have the same reference. Now, to properly check to see if two objects are equal, we need to check their properties. We need to make sure that all their properties are equal. So that's the job of this function, are equal. If all the properties of these two objects are equal, this function should return true, otherwise it should return false. Now the other function I want you to write is are same, address 1 and address 2. And this function simply tells us if address 1 and address 2 are pointing to the exact same object. In other words, they're referencing the same object. So go ahead and implement these two functions. When you're done, come back, continue watching. All right, I'm going to start by implementing the second function because that's easier. So to check to see if two variables are referencing the same object, use the strict equality operator. So return address 1 equals address 2. So if they are referencing the same object, we'll return true, otherwise we'll return false. Now with the other function, we need to check individual properties. So here we need to return a Boolean that is the result of evaluation of 3 conditional statements. So address 1 dot street should be equal to address 2 dot street. Here we use the logical AND. Next we add address 1 dot city. It should also equal address 2 dot city. Once again, we use the logical AND, and finally address 1 dot zip code should equal address 2 dot zip code. Now let's call these functions and see the results. So I'm going to do a console.log, call are equal, pass address 1 and address 2. And then I'm going to duplicate this and change are equal to are same. Save the changes. All right, I made a mistake here. So here we should use address 2. Save the changes. So you can see these two objects are equal. Their individual properties are equal, but they are not the same objects. There are two different objects in memory. In contrast, if we declare another variable here, let's say address 3, and we set that to address 1. Now both these variables are pointing or referencing the same object in memory. So if we call our same and pass address 1 and address 3, we're going to get true because they're pointing to the same object in memory. In the next exercise, we're going to work with blog post objects. In this exercise, I want you to create a blog post object with these properties: title, body, author, views, which represents the number of times this post has been viewed, comments. Now each comment should have a couple properties: author and body. And finally, another property that each post should have is live. That can be either true or false. So once again, you should use the object literal syntax to create and initialize a blog post. Give each property some value. The actual value doesn't really matter. I just want you to get comfortable with the object literal syntax. All right, here's the solution. So let's create a post object using the object literal syntax. We set the title to A, body to B, author to C. So all these 3 properties are strings. Now views should be a number. We can set that to 10. Comments should be an array because we can have multiple comments. So we set that to an array. Now each comment should have 2 properties. So each comment should be an object. So here, once again, we use the object literal syntax to initialize a comment object. We set the author to A and body to B. We can have another comment in this array. Let's duplicate that with different values. And finally, we should add the isLive property. So isLive, we set that to true. And then let's do a console.log of post. inspect this on the console. So you can see the comments property is an array with 2 objects. If we expand this, you can see the properties of each object. We've got author and body. In this exercise, once again, we're going to use a constructor function to create a post object. But this constructor function is a little bit different from the constructor function you wrote in an earlier exercise. So here's the scenario. Imagine we're building a blogging engine. The user is drafting a post, but they have not published it yet. What do you think that constructor function should look like? So spend a couple minutes on this exercise. When you're done, come back, continue watching. All right, let's start by creating this constructor function. We're going to call that post and note the capital P here. Now, what parameters do we need here? Well, obviously we need the title and the body and the author, but we don't need the number of views because the first time we create a post, views should be set to 0. And every time we view that post, we increment that value. So views is not something that we want to pass here. We want to use a default value of 0 when initializing this post object. The same is true for the comments property. For a new post that has not been published yet, we don't have any comments. So we don't want to add a comments parameter here. The same is true for the isLive property. We want to set this to false by default, so there is really no need to add an extra parameter in this function. So you should aim to have functions with fewer parameters. The more parameters a function has, the harder it gets to use it, okay? So here, we're going to set this, the title, to the title argument. The same is true for the body property and author. Now, for the views, I'm going to initialize this to 0. Similarly, we're going to initialize comments to an empty array. So in the future, we can add new objects to this array. And finally, we set isLive to false. Now, instead of initializing this post object here, we're going to call our constructor function, pass the title, body, and author. And finally, let's log this on the console. So you can see author, body, and title properties are initialized based on the values that we passed here, but the other properties have default values. So comments is initialized to an empty array, isLive is false, and views is 0. Finally, the last exercise for this section. Here on Yelp.com, we have these price range buttons. So we've got inexpensive, moderate, pricey, and so on. If you want to implement this concept using objects, what properties do you think those objects should have? That's the focus of this exercise. So I want you to create an array of objects. Each object is what we call a price range object. It's one of these objects here. Now here we have 4 price range objects. In this exercise, you can create only 3 price range objects. Think about the properties that each object should have. So pause the video, spend a couple of minutes on this exercise, and when you're done, come back, see my solution. All right, I'm going to create an array called price ranges. In this array, we're going to have 3 objects. Each object should have 4 properties. One is the label that we display to the user, like a $sign. The second property is a tooltip. So here, when I hover my mouse over each button, you can see a tooltip. So for each price range object, we need this tooltip property. Let's call this inexpensive. Now we need 2 more properties, and with this we can determine the minimum and maximum price of a meal per person. We can call them min per person and max per person. So for this object, I'm assuming that the average price of a meal per person falls between $0 to $10. And this is important for filtering, because if you're building an application like Yelp, somewhere we need to store the list of restaurants. So we might have another array here, restaurants, In this array, we're going to have restaurant objects, and each restaurant object should have this property, average per person. Let's say the average per person is $5. Now, when it comes to filtering, let's imagine that the user only wants to see inexpensive restaurants. So this is the object that we're going to work with. And in this object, we can see the price per person is between $0 to $10. Now, we want to filter the list of restaurants and pull out those where their average price per person is between these values. So that's the whole point of having these two properties, okay? Now, similarly, we can create two more objects. We just need to change the value of these properties. So here we have the moderate price range. Let's say that's between $11 to $20. And finally, the last one is going to be expensive with price per person from $21 to, let's say, $50. So I hope you successfully completed this exercise. If not, don't worry. There are a million examples out there for you to practice. Whenever you're using an application, look at the features of that application, look at the concept, and imagine if you wanted to model one of those concepts using an object, what properties would you put in that object? The more you practice this, the easier it becomes. And that brings us to the end of this section. I hope you enjoyed this section, and thank you for watching.